This is lesson 5.3, finding square roots. I want to go back and do a little bit of review on simplifying radicals. So this is a topic you talked about a little bit in Algebra 1, but I think it's something that sometimes in Algebra 1 it's a little bit over people's heads. They just need more time for processing. So I'm going to talk about it again. This is actually called a radical symbol, not a square root symbol. It's a radical symbol. And the number that goes under the radical symbol is called the radicand. This number is called the index number. When there is no number there, it's a 2. It's an understood 2. Kind of like if we have a variable like this, the understood exponent is a 1. So when there is no number here, it's an understood 2. That's why we call it a square root, because the index number is an understood 2. Eventually, we'll start talking about cube roots, fourth roots, and we can put any number there. So we'll even talk about nth roots. But for now, let's stick with square roots and how we want to simplify a square root. So I'm going to start with square root 500. And I'm going to kind of show you the process for which I think about it, and then you can kind of do these in any way that you think is simpler, as long as we get the same answer. But whenever you talk about a square root of 500, that would be the same thing as the square root of 100 times the square root of 5. And we know that the square root of 100 is 10, because square root means I'm looking for a number that I multiply times itself. So this would become just a 10 without a square root symbol, and this would not simplify. So the square root of 500 and 10 square roots of 5 would be the same thing. If you put it in your calculator, square root 500, you'd get a decimal. When you put 10 square roots of 5 in your calculator, you would get the same decimal. They're equivalent. Kind of like 10 14ths is the same thing as 5 sevenths. They're equivalent. This is just the more simplified version, the version that we want to work with, so that we can add square roots and multiply and divide and things like that. All right, so the next example I have is 3 square roots of 12 times the square root of 6. So you noticed in the first example, I had a square root of a number, but I could break it apart into 2 square roots. So I'm going to kind of think about it like that. Because this is multiplication, the number under here does not have to be the same. We can put them under the same square root. So I could say this is 3 times 1, because there's a 1 here, times the square root of 12 times 6. Now, I'm not going to multiply the 12 and the 6 together, because eventually I'm going to try to break it apart into its factors like I did in example 1. So I'm going to start thinking about the factors of 12 and 6. And as I think about the factors of 12 and 6, I want to try to break it apart easily so that I have square numbers under here, or perfect square numbers. So when I break apart 12 into its factors, I want to use 3 times 4 rather than 2 times 6, because I know that 3 times 4 gives me 12, and 4 is a perfect square. And now I'm going to break apart 6. The only way it breaks apart is 2 times 3. So now I'm going to look for perfect square numbers. The square root of 4 is 2, so I'm going to cross off the 4 and put a 2 on the outside. And then I notice I have 2 3's. So really, 3 times 3 becomes a 9. And the square root of 9 is 3. So when I have 2 of the same number, that becomes a perfect square, so it brings one of that number outside. Let me say that again. 3 times 3 would be 9, and the square root of 9 is 3. So when I see 2 of the same number, it brings 1 on the outside of the radical. Now there's nothing left on the inside. So my answer is just going to be square root of 2 on the inside. And then on the outside, I'm going to multiply the numbers that I brought out. So 3 times 2 is 6, and 6 times 3 is 18. So 3 square root of 12 times the square root of 6 is simplified as 18 square roots of 2. This only happens when you multiply, that you can put them under the same radical. If I tried to add square root of 12 plus square root of 6, I could not do that because these are not the same. It only works with multiplication, and we'll talk more about how to add and subtract with radicals later. All right, here's the third example of a review. Something like the square root of 25 thirds. So this time, instead of a multiplication problem under the radical, I have a division problem. So we've got to rationalize the denominator here. So this problem splits apart into square root of 25 over square root of 3. And we know that the square root of 25 is just 5. But there's a rule in math that says whenever you have simplified a radical, you cannot leave a radical in the denominator. It's kind of like a fraction. You always want to simplify it or reduce it. So here I'm going to simplify the radical by taking this by some number. And there's only one number that you can take a number by, multiply by a number, and you don't change the number. Like if I had the number 5, and I wanted to multiply it by something, but not change the number, I could multiply it by 1. Because 5 times 1 is still 5. So I'm going to multiply this times, I call it the big 1. But we know that 1 can be any number over itself. So I'm going to choose to make this the square root of 3 over the square root of 3. So here's what I get. 5 square root 3 over square root 9. And the square root of 9 is 3. So my answer would be 5 square root 3 over 3. Let's do another one like that. The square root of 2 over 11. So one rule of radicals is that you cannot have a radical fraction. So I've got to split it apart to the square root of 2 over the square root of 11. And now neither one of these simplify, so I'm ready to get rid of the radical. So I'm going to multiply by the big one, and I know the big one is any number over itself. So this time I'm going to choose square root of 11 over square root of 11 because I'm trying to get rid of the radical in the denominator. So on the bottom now I have square root of 121, which is just 11. So notice the big one that I'm choosing is always going to be whatever is in the denominator because that's the radical that I'm trying to get rid of. So now on the top I have square root of 2 times square root of 11, which is square root of 22. So my answer would be square root of 22 over 11. All right, let's move into solving with radicals. I'm going to stop and make a separate video for that one.